Hey guys, welcome to our Injective Global Virtual Hackathon. I'm Bojan and I'm a tech lead at Injective Labs, and today I'm going to be building some decentralized applications on top of Injective. But first, what is Injective? Injective is a layer 1 blockchain built for finance. It offers out-of-the-box financial primitives for building decentralized applications. In addition to that, it also has an open and permissionless smart contracts layer, which provides advanced capabilities in building robust and innovative decentralized applications. Injective is natively interoperable with several well-known blockchain networks such as Ethereum, Solana, and all IBC-enabled Cosmos chains like Cosmos Hub, Osmosis, Stride, and etc. The interoperability not only allows Injective to enable users to bridge assets from multiple blockchain networks, it also allows for transferring arbitrary data like Oracle prices and etc. The most comprehensive way to expand the Injective ecosystem is by providing the best developer experience to developers building on top of Injective. This means providing not only support for the complex financial primitives on the chain itself, but also tooling that makes accessing these powerful primitives easy and intuitive. The biggest lift developers need to do to get up and running with their exchange or any other decentralized application built on top of Injective is to build a UI. It's worth mentioning that every developer tool provided from the Injective Labs team is framework agnostic, which means that developers can use their preferred framework choice to build the UI itself. This can be React, Vue, Angular, and even if you are building a mobile app, it can be React Native, Quasar, or any other framework of your own choosing. For the bravest one, we've also covered them as well. We offer tooling for building advanced CLI applications and bots in a Node.js environment. Within this presentation, we are going to build two decentralized applications on top of Injective. The first one will be a decentralized exchange and a bridge from Ethereum to Injective called Dexly. Building decentralized exchange is one of the main use cases of developers deciding to build on top of Injective. And the reason is simple, just like we said before, it's the financial primitive that Injective offers out of the box. So developers can just bootstrap their decentralized exchange in an instant. And then part 2 is a Cosmos smart contract example application. We're going to build a UI which interacts with a simple smart contract deployed on the Cosmos layer on top of Injective. And a side note, we are not going to focus on the HTML and CSS part while building these decentralized applications. The core focus of this presentation will be to set up an example repository, include the Injective Labs NPM packages, and start interacting with Injective. So if you see me skip some parts of the video, it's because I don't want to spend time on writing HTML and CSS. Okay, so let's dive into it. First, the Dexly, the decentralized application on the decentralized exchange on top of Injective. So let's start building it together. Before we start building it, let's define the scope and the feature set it should have. The features include, but they're not limited to for this presentation, connecting to a wallet. In this case, we are going to use MetaMask, sending assets on the Injective chain itself, showing the order book of the INJ USDT market, executing a spot limit order, and then we are also going to include a bridge from Ethereum to Injective. Okay. So first we are going to open our code editor. I have a folder called hackathon. As you can see, it's empty. So for this particular decentralized application, Dexly, we are going to use Nux3, and we have a nice guide on the Injective TS wiki page, which you can always open on GitHub on the Injective TS repo, click on wiki, and scroll down below. We have configuration here, Nux3. And this is the framework that we are going to use to build the Dexly UI. So first, we are going to install Nux3. Let's open the docs and do it together. So npm nux maxi init, and then the project name, it's Dexly. As you can see, it's quite easy. And then we are just going to install the dependencies. I'm going to pause the video so we don't waste time on installing the dependencies. After it's done, let's open the folder. And we have all these files here. And then let's install all of the Injective Labs dependencies. And since we are going to need a wallet connection, we are going to install the wallet ES package itself, as well. So we're going to add once the packages are installed, let's configure Nux to include some modules that we need for the decentralized application. Let's add Pinia is a state management library. Let's just follow the documentation here, and we are going to add it to the modules array. And we're also going to use view use, which is one collection of view composition utilities. And then for Nuxt, we are going to install these two packages and also add it to the modules here. View use Nuxt. And finally, for styling, we are going to use Tailwind CSS. You can find the guide here, it's quite easy as well. Add and then add it to the modules. We're going to delete the app component because we don't need it. Then if I go back to the configuration, we need to add some polyfills. We need to ensure that our application will work in the browser properly. This means for the particular builder that we are using, Vite, it's the standard of the Nuxt 3 framework. We need to ensure that it works. In the final bundle, we include polyfills for no standard libraries like buffer, crypto, events, and etc. And we need this because most of the libraries that we use in the Web3 space need access to at least the buffer and some other crypto-related dependencies. So let's add these two libraries, and then the other one as well. Then we can just copy this config, include it in our folder. These three are related to an ESM, something called ESM build. If you are familiar with it, it just means that it will build the project using the latest standard, the ESM standard, and it will include things like tree shaking, so your bundle, the end bundle will be smaller and include only the dependencies and the functions that you are actually using in the project. Then we have the types array for view use and Pinia that we are going to use in our project, and we exclude compiling null modules, and this is just the standard TypeScript stuff. And then, just like I said, we need to add a buffer. So let's do that. We're going to add it as a plugin. Oops. I'm going to create a new folder called plugins. I'm going to add the buffer.client.ts, and this client suffix is just showing, just telling Nuxt that it's only for the client, to include this plugin only on the client side. And then we can just copy this whole node Nuxt config. I'm going to add it here. Let me just add, sorry, let me just add Tailwind CSS module here. So let's go one by one. The first one is to not pre-render the HTML of the application, because we are mostly working in a browser environment, and for all of the wallets we need access to the extensions, we need access to the local storage, so it's better to have the app rendered on the client side. We have the modules, we have TypeScript checking on when we build the application for deployment. We have automatic imports of the store folder, which we are going to discuss a little bit later on. But this means that it will be all the types will be automatically included in the components and pages that we build, so it's easier to access them. This is just some Pinia stuff to include the definitions of Pinia stores. We have the plugin, which we are going to include on the client side only. We have a source map configuration here to just, if we want to generate the source map on the client side only, for not the server, only for the client dependencies. And we have some Vite related config. This is to define the process env in case we use it somewhere, because Vite uses the import meta.env, not the process env like Webpack. Just like we said, setting up some node and crypto polyfills. We're going to disable building the source map when we generate the application. We have some rollup options. This cache false just means that on each build the dependencies are going to be rebuilt. So it's not going to use some cache to speed up the development, but this means that sometimes if you, let's say, install a new dependency, you will Vite doesn't know that you installed a new dependency, so in the end build you are going to miss out some of the JavaScript that you need, basically. So it's just safer to disable the cache. And this is some feed related issue that we have for the plugin. You need to exclude optimizing the FS events package. Okay, so now let's see if everything works. Let's just create a page folder, and all these folders are basically following the Nux3 convention of naming the folders. Pages is the pages that you are going to have. So, and yeah, obviously you can find more information about the pages on the Nux3 documentation. Hello Dexley. So let's build the app. Go back, local store, hello Dexley. So we set up everything properly, and we can start building Dexley. So what I want to do with most of our projects when building UIs is to have an app folder where I'm going to store the business logic and export some commonly used utilities and functions that I'm going to use across my app. So I'm going to create a service.ts file here, and I'm going to start importing all of the functionalities that I need from the SDK or the wallet TS packages that we just included in our project. So first we are going to export a chain ID constant. Let's include TS types. We are going to operate on mainnet because why not? And then we are going to have a network. Let's import them from the network package, and we are going to use mainnet. And you can find a little bit more information about the networks package on the Injective TS, and then you have the networks here. Basically what it does is just offers a way for developers to access public mainnet infrastructure, so you don't have to spawn your own infrastructure, like all of the APIs, the Sentry nodes, accessing to a Tendermint, RPC, and etc. This is useful when you're building decentralized applications because it will just give you out-of-the-box infrastructure to use in your project, whether that's testnet or mainnet, or just like I said, you don't have to care about the infrastructure. You can just use these predefined endpoints and access to the data or the access to the chain itself, to whether it's querying the chain or sending transaction to the chain itself. Okay, and then let's get these endpoints that I just talked about. Const points get network endpoints. Let me just restart my VS Code because it doesn't have autocomplete. Endpoints, and then we pass the network here. And we are also going to need Ethereum chain ID, because we are going to use MetaMask as our wallet for interacting, for broadcasting, signing and broadcasting transaction on Injective for this particular example. Okay, so now, just like I said, we are going to use MetaMask to connect to our Dexly, and to do this, we have something called wallet strategy, and you can learn a little bit more about it on the Injective TS wiki. Just like it says here, the main purpose is to offer developers a way to have different wallet implementations on Injective. They're exposing the same strategy, which you can use out of the box to get the addresses of the connected wallet, send the transaction, sign a transaction, and everything is just abstracted away for you, the developer, to use it with just one simple method call. So let's instantiate the wallet strategy as shown on the example here. I'm going to import it from the wallet TS package. Then I can just copy the wallet strategy here. And one thing to note is that I can exclude the Ethereum options if I don't want to use an Ethereum native wallet. If, let's say, I want to use only Kepler, I can just remove this and I'll have a wallet strategy that works with Cosmos native wallets only. But since we are using MetaMask, we are going to include the Ethereum options. Here, let's just copy this. But since we're using Vite, this has to be import. And I'm going to create the example. It's going to need the key, and I'm going to create the .env now. So now that we have the key, we have the RPC and WebSocket endpoints from Alchemy. We created the wallet strategy, and one thing that we are also going to need is something called the message broadcaster client, which we can also import from the wallet TS. Message broadcaster. Let's make an instance. And then the network. And what can we do with the message broadcaster? We can also open the Injective TS wiki, find the message broadcaster, and what it does behind the scenes is just a class to prepare, sign, and broadcast transaction using the wallet strategy. So if you, on the wallet strategy you select Kepler, then the message broadcaster will use Kepler to prepare the message, sign it, and then broadcast it to Injective. This is just a convenient way for you to broadcast transactions without the need to know the underlying logic of how to prepare them, how to sign them, and broadcast them. So this is just done, as you can see here, with just one simple API call. API call on the message broadcaster class. And then for this particular example, as we said in the scope, we are going to need to query the bank balances of the user. So we are going to export the chain gRPC bank API. Let's import it from the SDK TS bank. And because this is, we are querying the chain directly, we are going to use the gRPC endpoint. And then since we said that we need to like fetch the market, this in INJ USDT market, and fetch its order book, we are going to import the indexer gRPC spot API. And for this, we need to use the indexer API endpoint. Okay, so we are set up for now. Obviously, you can include as many APIs and APIs as you need from the SDK-TS, and you can find all of them in the querying section. For example, if you want to query, I don't know, your delegation information, you can just click on staking and you'll find how to query like the whole example here. For this particular decentralized application, we are just going to query the balances of the user using the change gRPC API and then the fetch balances method as shown here. Obviously, this is the same for the indexer API. You have all of the examples here. For this particular case, we are going to use the spot API, and you can just fetch, using the fetch markets method, you can fetch all of the markets on the chain. And then obviously we have the order book for a market, and this is what we are going to use to fetch the order book for our particular example. Okay, so now that we have the services load in, the way that I want to structure the way that I usually structure my applications is that I have a centralized state management where usually they have actions. In this case, we are going to use Pinia, just like I said in the beginning. And the user, when he interacts on the UI, he calls a particular action, whether to fetch data from the chain or any other API, and then the state of the application will get updated, and this will be reflected on the UI itself. And when you, let's say, want to make a transaction, again, the user interacts on a form, clicks a button, and then an action will be triggered within the store, which will create the message itself and then broadcast it to the chain, to the injective chain. So when using Nux3, all of the store logic lives in the store folder, and first we are going to create a wallet store. This is where we are going to hold all of the logic for connecting the user's wallet to our application. To save some time, I'm just going to pause the video and write the implementation. Okay, so now that the implementation is done, let's see the store itself. It has two fields in the state: the address, the user's connected wallet address, and the balances of the injective address that's connected. And we have three actions. The first one is the connect action. This just uses the wallet strategy to get the addresses from the currently connected wallet. In this case, the default is MetaMask. Because we get Ethereum addresses, we need to convert them to injective address, and then we just update the state. And we have one more, which is the fetch balances action, and it will just use the chain gRPC bank API to fetch the balances for the connected wallet address and obviously update the state. And we have one more action, the transfer action, and this action will just prepare the message, which, just like I explained, you can find. Actually, I didn't discuss about this. So the way that you submit transactions on Injective is by packing messages, and these messages are a way to tell the Injective chain what do you want to execute on the chain itself. And the message sent is one message from the bank module, which just transfers funds from one address to another address. And then using the message broadcaster, we are just going to broadcast the transaction to we're going to pack the message in a transaction, sign it using the wallet, and then broadcast it to Injective. And you can read a little bit more about this whole transaction flow on the Injective TS, and then prepare, sign, and broadcast here. Even the overview is a nice read. And then if you want to see all of the messages that we have on the Injective TS level, on the SDK TS package, you can just reference them in the core modules sidebar here in the wiki, and search for the action that you want to perform. Let's say I want to send from one address to another. I click on bank, and you can see a whole example here about how to achieve that, how to construct the message, pack it, and then how to construct the message, pack it into a transaction, and send it to the chain. Okay, so now let's start writing some HTML and CSS so we can connect the UI with this centralized store, which will then trigger some business logic from the services that we wrote here, and either update the state or submit a transaction. So first we have the index page. On the index page we are going to show a connect button if the user is not connected with their wallet, or show go to the trade page, which will be the second page, where we are going to do some we're going to show some data and allow the user to make a trade and transfer funds from one address to another. So I'm going to pause the video and write the component, the page itself. So now that we have the page, let's go through the code. We are using the wallet store, and we have one function that connects, that calls the connect action within the wallet store, which behind the scenes connects the wallet that the user chose. In this case, it's MetaMask, and get the address and store it in the wallet store state. And here we have a small, simple, just blue button that calls the function, and that's about it. So if I go back to my app, if I refresh, actually let's rebuild it because I changed the page. Let's see here, we might have some problems. No errors actually. Okay, so I have the connect wallet, but it's on top, so let's make a layout. This is also a standard on Nux3. This is a standard folder structure on every Nux3 app. So, and the default layout for all of the pages is just called default. So let's build it. And we can just make everything screen, sorry. And then let's add some color. And then the slot is the page that gets inserted inside. So now it's centered, which is what we want to achieve. So now if I click on connect wallet, I have this error. Let me show you. So no match for name trade because I don't have the trade page, which I redirect here to when I actually connect my wallet. So let's just create the trade page for now. Hello from the trade page. If I go back, I refresh again, connect the wallet, and then I'm on the trade page. What we want to do is not allow the user who's actually, when you're not connected, we should disable the access to the trade page, and this can be achieved through middlewares. So let me show you how to quickly do this. Is again, middleware is one of the folders that you can have on Nux3, and here we are going to create a connected middleware that export default define Nux middleware, and that we need to check whether the user is connected within our app state, and we can do this by, let's import the wallet store here, and if wallet store that is user wallet connected, which is a getter, which just checks whether we have the address set in the state. If the user is not connected actually, then we are just going to the next page. And to call this, to make this global, we can just add .global.ts suffix, but we don't need to be global because we are going to call it from some pages only. And to do this, we are just, let's keep this for now and have a script here set up using TypeScript. we can use define page meta and then middleware, and we have the connected middleware. So now if I'm going to access the trade page directly from the app without being connected, it will just redirect me back to the home page. So if I click connect, everything works just as expected. Okay, so what we want to show on this trade page is two forms. The first form would be the transfer to another Injective address form, where we would allow the user to transfer Injective from one address to another. And then on the second part, we are going to show the order book for the Injective spot USDT market and allow the user to create a spot limit order on that particular market. So again, let's go back to the code, and to save some time, I'm going to pause the video and write the code. So now that we coded the page itself, I added a new store exchange, which we are going to code in a bit. Let me just explain this this code. So on mounted, when we actually load the page, we are going to fetch the balances of the user we have here. So it's going to call the fetch balance action. This is just using the JavaScript alert. We don't have any toast or notification for this example, the decentralized application. And then we are going to we're going to fetch all of the markets that we have on the chain, and after they are fetched, we are going to fetch the order book for the Injective USDT market, and obviously just update the order book every 5 seconds. Here we have a simple HTML just showing the wallet address that the user is connected to on Dexly, and just a transfer form and a simple trade form. So let's write the code for the exchange store. Let's make it first here. Exchange.ts, and I'm going to pause the video to write the code. Okay, so now that we have the exchange store, same, we have some state, the order book of the Injective USDT market, and the markets fetched from the chain. So now, okay, let's see this error. Yes, let's define types for file here, and it will export enum order type, which is by one. This is how the order type is represented on the chain. So we're just going to have buy and sell for this, for Dexly. Okay, now it's imported. And within this store, we have a couple of action methods. The first one is fetch markets, which will fetch all of the active markets which have INJ based denom, and this PEGI quote denom. This is actually the USDT denom on the Injective chain, and then update the state. We have the fetch order book action, which will fetch the order book for the INJ spot market, and this is just a getter which will just find the market within the markets array in the state which has the INJ based denom. And finally, we have the create limit order action, which just accepts some parameters, creates the message, and then broadcasts it to the Injective chain. Obviously, sub-account ID is something that we need, so you can use this utility function to get the sub-account ID for that particular message. And you can find all of the messages that are, just like I said, you can find all of the supported messages on the Injective TS wiki that we support on SDK-TS. For this particular example, we are using the create spot limit order. So if I go back to the TS wiki, I can click on exchange, search for it, and you can find how to create this particular message and what all of the fields mean, and how to basically convert the messages from a human readable format to the chain format that the Injective chain accepts. And you can find more information about this on the Injective TS wiki, how to convert numbers and how to represent them, and most of this is already abstracted away from the user, so you can just pass raw values directly. But yeah, just reference the Injective TS wiki and you can find all of the examples there. Okay, so now that we have the store, let's go back. Let's rebuild the app. Let's go back. We are opening the trade page, but it's going to be redirected to home page. And the way to resolve this is that if you wanna have the user stay connected on the app itself, you can persist the state from Pinia to your local storage, and then when you refresh the app, you basically hydrate the app state from your local storage, and this way you can make the user feel like he's always connected on the app. Because Injective is decentralized, we don't have any emails or passwords or whatever. You just use your wallet, and this is one way to keep the user connected to the app itself. So just persist it in local storage and then hydrate the app state when you load the app. And you can use some, you can search online for some solutions. It should be quite easy. So okay, let's connect the wallet. We have a blank page, so something is not working. Let's open the console. Alright, so we have, oh yeah, so the trade and the transfer components are not implemented. Let's add them. We have another folder, default folder for Nux3. It's called components. Here we are going to create the trade, that view component. Let's create something default for now. Trade, and then we have the transfer. Let's rebuild. Obviously I'm not going to record the coding of these components in video because it's just basically HTML and CSS. Okay, let's refresh, connect. Okay, connect. Voila. So we have the wallet address that's connected, and we have these two trade forms here. Okay, so now I'm going to pause the video and code both of the trade and transfer forms. And bam, we're back. So we have both the trade and the transfer component. Let's go through the code. For the trade, we have the exchange store. We have a simple reactive form which we are going to use to pass the create limit order action. So we create the limit order itself, and here we have two computed properties, buys and sell, which are just computed properties from the exchange store for the order book of that particular market. We have one function handle select order type. When the user wants to switch between buy and sell, we are updating the form value from the user selected value. And here we have just some basic validation, so the user actually sends some amount and price. Here we have a simple HTML form, just a button to switch between buy and sell. We have some labels and input. It's just basic HTML, and we have a button to create the limit order. And here we have the order book of the USDT, of the INJ USDT market. And here we are just looping through the records of the order book itself. This is the buys and these are the sells. We need to create this price level component itself, so let's do it now. And I can just, because this is a quite simple component, I can just do it on the video. So script, it's TS, we're using TypeScript, it's setup, and we'll have some props passed. We'll have this buy prop, whether the record is buy or sell, and then we have the record itself. Type is object, as prop type, it's price level from the SDK TS, it's required, and then we are going to basically, when we fetch the order book details from the index API, the values are the values are not human readable. They're fetched exactly as they are represented on the chain itself. So we need to convert them in a human readable format. So first, let's do the quantity. And again, for all of this information, you can reference the Injective TS wiki or find some or reference the examples of how to transfer data, whether it's like fetching from the chain or sending to the chain. So you can just reference the wiki of how to do these conversions. So it's a computed property which returns this utility function. This utility class, big number way, basically has one method to base, which will just convert a way representation of a number to a human readable number. In this case, the props.record quantity, and because it's the INJ has 18 decimals, we add 18 here. So that's for the quantity. Let's do the same for the price. For spot markets, the way that the price is represented to chain, to make it in a human readable format, you have to basically divide by the quote token decimals. In this case, it's USDT, and USDT has 6 decimals, and then subtract the number of decimals for the base denom, which in this case is NJ and has 18 decimals. And then the total of the notional value of the record is just quantity times price. And then here we can just make a simple table row which has 3 TDs, all of them have the monofont, text right, and we can make them a bit smaller. Okay, the first one is the price. Let's have the price fixed to 4 decimals. Let's do the quantity to like 4 decimals again, doesn't matter, it's up to you. And then the total again, 4 decimals. Okay, let's rebuild the app. Okay, we connect the wallet, and now we see the whole order book of the INJ USDT market. Okay, let's make it a little bit more beautiful. Let's add text green 500 if it's a buy, or text red 500 if it's not a buy for the price. There you go, nice. Okay, so as you can see, okay, let's I forgot one more detail to explain the transfer form. The transfer form component. So let's go to the component itself, and as you can see, same approach. We have the form. From the wallet store, from the balances, we find the user's INJ balance, and then we convert it to base. Again, the way that it's represented on chain is in not a human readable format, so we need to convert it to a human readable format, and the way to do this is just use the big number and way utility function from the utils package, and since INJ has 18 decimals, that's how we convert it to the human readable format. And we have a handle submit method which just adds some validations, and then from the wallet store we pass the form to the transfer action, which again creates the message and then uses the broadcast method on the message broadcaster, which will prepare the transaction, sign it using the MetaMask wallet, and then broadcast it to Injective. Obviously we have some HTML here, the label, inputs, and the button itself. Okay, so now that we have this, let's try it out. As you can see here, this wallet has 0.72 INJ, so let's just try it out. Let's send some INJ to the address itself. If I click transfer, I get a pop-up on MetaMask. I sign it, waiting for the transaction to be included, and as you can see, we have transfer successful. Nice. So we just built a simple transfer form on Injective. And then for the trade, we can switch between buy and sell. Obviously, always buy. And then for the price, we can do something like 5. And then for the amount, we can specify the amount. Click on create limit order. We have the signature request again, sign. Wait for the transaction to be included, and then we have the limit order created successfully. Nice. So within 40 minutes, we've created a simple UI to fetch the order book of a market and allow the user to create a limit order. Obviously, this can be improved, but for Dexly is enough, and for just like to show an example of how you can use the Injective TS packages and build a simple UI within 30 minutes. Okay, so now let's get back to the presentation, and yeah, this is the Dex. So now within Dexly, we are also going to include a bridge for Injective from Ethereum. The Injective Ethereum bridge enables the Injective chain to support a trustless on-chain bidirectional token bridge. This means that ERC20 tokens from Ethereum can be instantaneously converted to Cosmos native tokens on Injective and vice versa. Okay, so how does this bridge work? You can find more information on the Injective TS wiki on the bridge section Injective Ethereum. I'm going to try to explain it briefly within the presentation. So there are 3 parts of the Peggy bridge. The first one is the Peggy contract, which is deployed on Ethereum, and this is where all of the ERC20 tokens that you want to transfer to Injective are locked. Also, when you try to withdraw from Injective, are unlocked and sent to your Ethereum address. Then we have the Pega orchestrator. It's an off-chain relayer that every validator on Injective runs. Basically, the reason why we have this orchestrator is to apply the same consensus mechanism we have for validating transactions on Injective for deposits and withdrawals within the Peggy bridge. This means that the Peggy bridge is secured with the same consensus mechanism that the whole Injective network is secured. And finally, we have the Peggy module on the Injective chain, and this module helps burn and mint new tokens. For example, when you transfer USDT from Ethereum to Injective, the ERC20 gets locked in the Peggy contract. Then the Peggy orchestrator validates the deposit, and then the Peggy module will mint USDT representative on the Injective chain. If you want to withdraw, it will burn the tokens. When the Peggy orchestrator validates the withdrawal, the Peggy contract will unlock the ERC20 and send them to your address. So let's add this bridge to Dexly. Before we start building, let's define the scope, and the features that are going to be included is to transfer funds from Ethereum to Injective. So let's build this bridge. Let's go back to the code. First, let's add a link to the bridge page itself on the trade page. So we can do it here. It can have a class. Let's separate them, and then pointer bridge, and then we can have a handler function just redirect. Let's comment this here. And let's create the page here. Hello from bridge page. Okay, let's go back. Connect. We have the bridge link here. We click hello from the bridge page. Nice. Okay, let's go back. I'm going to pause the video and build and write the code. Okay, so this page is quite simple. We have one more store that we're going to build, the bridge store, and again, secured by the connected middleware. And when we mount the page, we are going to fetch the ERC20 balances for our Ethereum address on Ethereum, and we just have a trade link that goes back to the trade page. We also need to build this bridge form component, which we are going to do after we build the store. So let's make the store now. And here we are going to perform some magic, and the code will be shown in 3, 2, and that's it. We have the code. So now we need to just define a couple of more services. Let's install the SDK UI TS package, which has this fetch gas price utility function, which will fetch the latest gas prices for Ethereum. And let's define the Web3 client, Web3 composer, Web3 broadcaster clients from the services. And what this will do, the Web3 client we can use to fetch users balances and allowances for ERC20 transfers. Web3 composer is just a utility class to generate Ethereum transactions, and Web3 broadcaster the same as the message broadcaster, is just broadcasting Web3 transactions. So let's go to the services and let's get all of the services up and ready, all of these instances of classes. Okay, so now that we have these 3 classes, let's use them in the bridge store. There's some error. Send transaction, right? And then we have TX, and then the address is the Ethereum address that's connected. Okay, nice. Let's open the bridge page now. Okay, let me compile the app. Bridge. Okay, yes, we are missing the bridge component, so let's build it. And we are going to do some magic in 3, 2, 1. Okay, so let's see what does the bridge component form do. Like, we have the form, we use the bridge store. This is the balance, the ERC20 balance. We are going to allow the user to select between whether to transfer INJ or USDT from Ethereum. And this is the, again, we need to convert from WAY to a human readable format value. So this is the computed balance property. It just searches between the ERC20 balances. Actually, we haven't explained the bridge store, so let's just do it now. We have just ERC20 balances in the state, and we have 2 methods, 2 actions. The first one is the fetch ERC20 balances, which will just fetch the ERC20 balances for INJ and USDT for the connected wallet address. And then the second one is the transfer to Injective, which will get the gas price, the current gas price from these utility functions that we have on Ethereum. Then it will transfer the amount from human readable format to the WAY format, and just use the composer to get the PEGI transfer transaction and then broadcast it to Ethereum. Let's go back to the component, and again we have a single handle submit function, which will just call that action within the bridge store and broadcast the transaction on Ethereum. Okay, let's go back, connect wallet, bridge. Okay, something is off. Let's see. Pages, bridge. This is the bridge. That's fine. Okay, let's make this pointer. Okay, let's see. Okay, so now that we are on the trade page, let's click on the bridge, and we have this little form again to bridge to Injective from Ethereum. We have to can select INJ or USDT. So let's transfer 0.1, and considering this is on mainnet, yeah, let's just do it. Confirm the transaction. We'll wait a little bit for the transaction to be included on Ethereum, and then the balance to be reflected on Injective. So now, as you can see, I have the balance was reduced on Ethereum and balance updated on Injective. So I think that's about it for the part one. We've built the bridge. We have a fully functional Dexly. Now let's go back to the presentation. So now that we are done with the second part of the first decentralized application, let's do a recap. So we have a decentralized application that basically allows you to connect your wallet, send Injective to another address, fetches all of the markets that we have on chain, fetches the order book for INJ USDT spot market, allows you to create a limit order for that particular market as well, also fetches your INJ balances on the chain, and then we also have the bridge, which allows you to transfer assets from Ethereum to Injective. So that's it for the part one. We are going to break the video here, and I'm going to record the new one for the second part, aka building a simple smart contract app on top of Injective. So peace.